we're going to look at gear ratios today. And before we look into gear ratios, I want to look at a picture here of engine, transmission, propeller shaft, and differential, and as it goes out to the wheels, just to give you some perspective here. The purpose of a manual transmission or automatic transmission is to regulate the speed and the torque of the engine as it goes to the wheels in different situations. This would allow us to go, let's say, up a hill and have lots of power going up a hill if we are in a lower gear, or if we're driving along and we want to go faster, we can put it in the highest gear and that will allow us to go faster as we go along. It doesn't necessarily allow us to accelerate more, that's a lower gear and higher torque, but it rather, the higher gear gives us a faster speed in the end. And so you can see that we have an engine right here. This engine, this is the crankshaft right here, and on this crankshaft it's attached to the input shaft of the transmission through the clutch. And then it heads off, the input shaft ends right there and goes down to this other gear, slides over to one of these, back up to the output shaft, through the propeller shaft to our pinion gear, which lines up with our crown gear and goes out to the wheels. And so we have a chance to play with the gears in here. This gear ratio is set already. These can vary and you can change them in a manual transmission to do whatever you need them to do for the situation you're in. So let's look at some gear ratios right now and see if we can calculate a gear ratio. So we have two gears here. We have one gear that is a larger gear with a lot more teeth and one with less teeth. And we're going to assume that this one with less teeth right now is our drive gear. In other words, if we look back at our picture here, this would be this input shaft gear that sits right there. And it's driving or turning all of the other gears. So this is the drive gear, and this one up here is the driven gear. In other words, it's being turned by something else. The way to figure out a gear ratio is to take the driven gear and divide it by the drive gear. In other words, we would count the number of teeth all the way around on this gear and write it on top, above right here, and then we would take the number of teeth here and put them on the bottom. And this is going to be our gear ratio. And that gear ratio tells us how many times this gear, the drive gear, needs to turn the driven gear one time. And so what we're going to do is we're going to figure it out and we're going to put a number in here to 1. So let's put some numbers in there. The numbers we'll put in here, just get rid of my lines here. So let's say that this gear has 40 teeth and this gear has 20 teeth. So we put it into our formula, we get 40 on the driven gear divided by 20 on the drive gear, and that equals, let's get our calculator, 40 divided by 20 equals 2. The answer is 2, and so we would write it like this, 2 to 1. In other words, the smaller gear or the drive gear needs to turn twice in order for the driven gear to turn once. Now, I said before that we could change speed and torque. Well, the higher the speed, the lower the torque. The lower the speed, the higher the torque. By how much, you say? Well, this is speed. If we switch these numbers around, this is our torque calculation. So on the output gear, we have 2 times the torque that we did on the input gear. So you can see that our speed and our torque vary with one another. As the speed goes up, the torque goes down. As the torque goes up, the speed goes down. You can't have both. You can only have one. And so that's the beauty of a manual transmission. Now, in a manual transmission, it's not all quite like that. It gets a little bit more complicated. And so let's look at this gear ratio right here. You can see that I've got these purple gears, one's right there, and then some green ones. We're going to give them some numbers. I'm going to put 40 teeth in here, and we're going to make this 10. And then I'm going to make this 20 teeth here and make this one 7. Now, one thing you need to know between these two gears on this shaft, that shaft is turning both those gears. So when one of those gears turns a certain speed, the other one is turning the same speed. This is called a compound gear ratio, and it gets a little complicated. This is the formula. Let's just shrink this down so I have a little bit more room. The formula is driven over drive for one set of gear ratios. You take that answer and you go multiply it by driven over drive. And if you have lots, you could have 3 or 4 or 10 or 100. You just keep multiplying them on to the end. So let's calculate this one. We've got 7 and 20. So I want to go 20 on the driven divided by 7. And that's going to be multiplied by 40 over 10. But we have to figure out the gear ratio first. So let's get our calculator, and we're going to go 20 divided by 7 equals 2.857. I'm just going to slide this up here. 2.857 times 40 divided by 10 equals 4. Now what I'm going to do is I'm going to change this a little bit. We always make it to 2 decimals. That's the way they do it for some reason, but we're going to do it that way too. And this is 4.00. So we multiply those two together, and we've got 4 times 2.86 equals 11.44. In other words, every time this 40-tooth gear turns once, this input shaft has to turn 11.44 times. So 11.44 turns of the small input gear makes the output gear turn once. However, every turn of the input gear gives you 11.44 times more what? Torque. That gives you more power. And so you can see with a compound gear ratio between two sets of gears with the middle ones attached to one another that we can gain a lot more torque in that situation without having really small gears on this side and really big massive gears on the other side. Good. So let's go back to our original picture. So we're going to head out of our crankshaft into our input gear. That goes over to this gear. So that's a gear ratio right there. Driven over drive. And this gear is attached directly to this one over here, and it drives this gear. So that is driven over drive. And that gets transferred all the way through to my pinion gear, to my crown gear. This is the driven, and this is the drive. So if we calculate those all together, we're going to end up with our final drive for the number of rotations of our wheels as compared to the number of rotations of our crankshaft.